This lesson is about solving equations with absolute values. But first, let's remind ourselves what absolute values are. Absolute value is essentially an answer to the question, how far is something from 0 on a number line? For example, if I asked you the absolute value of 5, by the way these bars represent the absolute value, the absolute value of 5 means how far is 5 from 0? Well, here's 5. How far is it from 0? Obviously 5 spaces. Suppose I were to ask you the absolute value of -3. I would be asking you, how far is -3 away from 0? Well, this distance is 3 spaces. What about the absolute value of 0? Well, how far is 0 from 0? 0 spaces. Now, on first glance, you might think, oh, absolute values are things that remove negative signs or turn negatives into positives. Well, there's some truth to that. That's probably not the best perspective to have, because later we're going to be looking at expressions like this. And if you think absolute values are magic bars that turn negatives into positives, you might make that mistake. So watch out for that logic. So now, let's look at an actual absolute value equation. Before I show you a technique to solve this, let me just give you a sense of what it is we're looking for. To solve an equation means x is some number. We're trying to find out what that number is to make this a true statement. Well, you can tell by looking at it that if x were 2, this would become a true statement. The absolute value of 5 is 5. That's true. But it turns out x equals 2 isn't the only possibility in this equation. Watch what happens if I were to put a -8 where the x is. If I were to work out the math, I would find out that I also get a true statement. It is true that the absolute value of -5 is 5. I'm not suggesting that you solve these by guess and check, as you've just seen me do, but I thought I would start this way just to show that absolute value equations can have two answers. So what's a more formal way about finding those answers? Here's a strategy. Interpret the statement as a distance from 0. X is some number we don't know. Therefore, x plus 3 is some other number. And if there's absolute value bars around the x plus 3, they're saying that x plus 3 is some number which is 5 spaces away from 0. Well, here's 0. What that means is, if I go 5 spaces away this way, maybe x plus 3 is there. On the other hand, if I go 5 spaces the other way, maybe x plus 3 could be over there as well. And these are both possible. So, of course, what numbers are 5 spaces away from 0 are 5 and -5. So how can we interpret this? If this is the situation, if x plus 3 and 5 are the same number, then we can find out what x would have to be using basic algebra. On the other hand, if x plus 3 and -5 are the same number, we can set up an equation, use some algebra, and find out what x would be in that case, thus leading to our two solutions. Let's take this problem and make one minor change. What if we change 5 into a -5? Watch out for situations like this. These equations have no solution. Why? Because an absolute value can never equal a negative number by the way absolute value is designed. It's always positive or 0. so watch out for those. Now, let's look at a more complicated equation. Notice that this equation has an absolute value in it, but that absolute value is embedded in a bunch of other math operations to make it not as clear as the previous problem. When I have an absolute value buried inside of other algebra, I generally recommend that you rewrite the equation, but put ABS, or absolute value, or some word where the absolute value used to be. Or better yet, put an A there. Because when we see this equation, it's a little more clear what we should do to solve the equation. Basic algebra here tells us that we should subtract 3 and divide by 10 to find out A. But remember, we're not solving for A. A isn't even in the original problem. A was just a substitute for our absolute value. But what we've managed to do by renaming the absolute value ABS, or simply A, is that we've been able to essentially get the absolute value by itself. We're not done solving this problem, but you can see that we've created a simpler equation out of a more complicated one. Some of you may prefer not to go through this trouble at all, and rather just to do the basic same algebra steps to the original problem without ever renaming it as ABS or A. And that's fine too. And whichever method you choose, you will end up doing something called isolating the absolute value. Getting that absolute value by itself, or isolating it, is really important. But why? Well, because once we've isolated it, we can interpret this statement here. When I see that statement, I think x is some number. 2 times x plus 5 is some other number. And the distance away from 0 of that number is 4. So if we interpret that statement this way, it'll be clear how we can set up an equation and solve it. So here's 0, and something is 4 spaces away from 0. Well, it could be 4 spaces this way. In other words, 2x plus 5 could be there. Or it could be 4 spaces the other way. 2x plus 5 could be there as well. These are both possible. But of course, what is 4 spaces away from 0? Well, obviously it's 4 and negative 4. So 2x plus 5 has to be one of those numbers. Let's consider this possibility first. If 2x plus 5 and 4 are the same number, I can use algebra to find out what x would be. By the way, some of the algebra is not shown here. On the other hand, let's consider this possibility. If 2x plus 5 and negative 4 are the same number, I can similarly use algebra to find out what x would be, thus yielding my 2 solutions to this equation. And that concludes the lesson.